everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken and Seth's brother, Joel. We're here to help you approach SAT math questions. Seth and I have a general policy. I'm really not looking at the problem ahead of time. This is from a calculator section, although I don't think the calculator is going to help you. And here we go. Give it two polynomials. Polynomial f and g are defining which of the following polynomials are divisible by 2x plus 3. So what's my first impression on this? What's Seth's first impression on this? You say, oh my goodness. This is the type of question that when you hit, you say, this is the hard one. Okay? Because it seems hard. This is the one you may want to skip to and go back when you see the pattern.
Wait, Seth. I got scared by it until I noticed that there is a difference between these two polynomials other than f being 2 times g, and that is there's a 4x at the end of this and a 2 here. And now I also see there's another difference. There's an x cubed here versus an x squared. Okay, so what Seth's looking for is a pattern. If you don't see a pattern on this question, then you will definitely not get it right. Okay.
In a reset, Seth, please.
Let me talk about seeing a pattern.
No, let me talk more about the approach.
It's important to notice patterns.
No, Seth,
and hold on, let me take it. I am taking it.
No, you're not.
We agree patterns are important.
No, but you have to say, no, it's more important to the approach. The approach is
the approach is to look for patterns.
That's right. And what happens if you don't see a pattern? You skip the problem.
I did see a pattern.
No, we're talking to the people who don't see the pattern. You have a PhD in math. You saw the pattern. What about most people who don't see the pattern? If you don't see the pattern...
Listen, tell us what the pattern is.
No.
So they know what we're talking about?
No, this is the approach thing. If you don't see a pattern in this question, what do you do when you have questions like this?
I give up. You take the floor for 2 minutes.
Fine. Good, thank you. We're talking about the approach. Right now, we don't care necessarily about the answer. We care about the approach. The approach is that if you don't see the pattern in questions like this, you give up. And you say, I just don't see the pattern, and you move on, and you don't waste time on this stuff. Either you see the pattern or you don't. Now, is it investment in time? You do this. You give yourself 30 seconds to see the pattern. You relax. Look for the pattern. 30 seconds, you got it. 30 seconds, you don't, you move on. Seth is a PhD in math. He saw the pattern in about 12 to 13 to 15 seconds, right? It's about 12 to 15 seconds, Seth? Seth saw the pattern in 12 seconds. He has a PhD in math. I sort of know where Seth's going, so now I sort of see the pattern too. I don't know how long, honestly, I don't know how long it would have taken me to see the pattern because Seth showed me the pattern already. Okay, Seth, since you're the one who saw the pattern first, why don't you show everyone the pattern?
I have the floor. Okay. I saw a pattern. The pattern that I saw was that f is equal to 2 times g. I saw that after about 12 seconds. Do you agree? Yes or no?
I don't know if that's certainly true. I don't know if I would have seen that.
So you say it's certainly true, don't you?
Yeah, it's true. F is twice G. Yeah. Because what you do is
50 seconds later. 50 seconds later, I saw another non-pattern.
Okay. Wait, F is
the term at the end of F is 4x. And the term at the end of G is 2.
What, F is not twice G.
That F ends with there's 3. Both of them have 3 terms. Both of them have the coefficients written above are twice the coefficients written below. That's a pattern, right?
Right.
It's a false pattern.
False pattern.
Yes.
F is not twice.
Why? I have the floor.
I know.
The term at the end is 2 for G and 4 times X for F.
Okay.
And to make it even worse, the first term of G is X squared. The second term is 2 times X cubed. This is wrong.
Okay.
I thought that there was a pattern here, and then about a minute later, I looked at it. I'll tell you the truth. I thought this was the pattern. This pattern would have resulted in none of these being divisible by 2x plus 3. And then I thought, well, they don't give SAT questions with none of the choices are true. So 50 seconds later, I looked at it again, and my original false impression was false.
Okay. Oh, it's good.
Okay, that's why.
It's good they didn't have that answer.
So to make please make the story short. Advice: look for patterns in SAT questions. Enough said.
Some SAT.
Second advice: when you think you have a pattern, make sure it really is, or discover that it isn't.
Okay.
Okay. So now we know that there's a misleading pattern, and now we have to. Now the problem becomes harder. So do you want to take it?
Well, okay. I'm trained like a dog. Okay, when we throw a stick, the dog gets the stick. I'm trained. As soon as I see a polynomial, factor. So as soon as I see this guy, I will write, and I know you like me to write in small. I will write x times 2x squared plus 3x plus 4. Now, I see that, nope. Should I write 2x squared plus, no,
6x.
wait. There's a mistake here.
6x.
By the way, every time you factor, you
plus 4x.
Be quiet. Every time I factor, I always double check to make sure I factored correctly. In this case, I factored wrong. So
what you did was right. Yeah, you factored. Yeah, you made you were very careless.
Right.
In writing that. That was a really careless move. Listen, Joel, take it easy. Take it easy.
Wait.
And factor the first polynomial very, very carefully and get it right.
Okay, that's not my point. My point is that after you factor anything, you check to see if you factored correctly. I caught my own mistake.
Yeah.
Every time you factor, you check. I checked. I made a mistake. So, of course, I'm going to go back and try again. I'm going to try a 2x here. I'm going to factor out a 2x. 2x. So I have x squared plus 3x plus 2. Wow. Now a pattern's coming in, right? Look at that. F of x is 2x times this. Ooh, look what I could do. I could say f of x is equal to 2x times g of x, can't I? I mean, I could. I don't know if it'll help me. That's interesting. That's certainly a pattern, right? Now, so which of the following polynomials is divisible by 2x plus 3? No. I mean, I really have to think about this. There's some sort of substitution thing going in. Some sort of algebraic substitution thing is going to happen here. Now, f of x plus g of x. Wow. Oh, this I really, 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 really have to think here. Which I'm doing on the spot, and Seth probably sees what to do already. Um, but it's just something uses this. Um, if p of x is f of x plus 3g of x, now f of x, you see this is interesting, right? F of x is 2x times g of x plus 3g of x, which means you could factor out the g of x and get 2x plus 3.
Mm.
So it looks like the one, this is it. Right? You see what I did? See, this is massive U substitution type. You're just substituting things in. See, I wish this wasn't here. I wish this wasn't here. So why don't we change color and be bold, okay? So let's go through these. F of x. F of x is 2 of x, g of x, plus g of x. So this is 2x plus 1. This one here is 2 of x, g of x, plus 3g of x, which is 2x plus 3. So that's the answer. This one is 4x g of x plus 3g of x, which is 4x plus 3. And this one is 6. See, it's 3 times this. So it's 6x g of x plus 2x g of x, which is, no, plus g of x, plus g of x, plus 2g of x, which is 6x plus 2. Do you see it? Does everybody see how I did that? No, we don't have interaction. So, Seth, am I doing that right? Did anyone follow me? It's real messy, but I don't have space. Do you see what we did? Are you frozen? Are you dumbstruck?
No. I'm doing it myself on the top.
On the top.
Yeah.
Okay.
I rewrote what you wrote here. I removed that silly x. So I rewrote this to say f is equal to 2x times g. And now we wonder what combination of f and g is divisible by 2x plus 3.
Okay.
So f by itself f is divisible by 2x. And then if I add, so x, this, if I write the gf, on top of the f, I'm going to write what it equals, 2xg. Now, this thing would be divisible by 2x plus 3 if I could write 3g here, which I could if I write 3g here. Okay? So f plus 3g is equal to 2x plus 3 times g. And so I need to get a combination that's divisible by 2x plus 3. I have to take 1f and 3 g's. And here, answer B is formed by taking 1f added to 3 g's.
So we agree.
We agree. Now, there's one thing we have to rule out. What if either f or g is divisible by 2x plus 3? So notice f is equal to 2x times g. And so the only possibility for f or g to be divisible by 2x plus 3 is for g to be divisible by 2x plus 3. But g equals x squared plus 3x plus 2. And Joel's reaction and my reaction when I'm doing a problem involving monomials is to factor it. Now, this is factorable. This gets factored into x plus 1, x plus 1 times x plus 3. Okay? Neither of which is equal to 2x plus 3. Or neither of which is equal to x plus 3 halves. And so 2x plus 3 is not a factor of G. So it's not a factor of arbitrary combinations of F and G. Okay, so the only case where the new polynomial is divisible by 2x plus 3 is B. Okay, none of these besides B has some number of F's added to 3 times the number of G's, right? This is 1 F and 1 G, 2 F's and 3 G's. That's not 1 F and 3 G's, and 3 F's and 2 G's is not 1 F and 1 and 3 G's. Okay, so that the So this is I think this is one of the harder questions in the SAT.
Right, that's right. So the faster you figure out that it's a hard question, the better it is to either look for the pattern or just forget it. We don't know.
So be careful. This is a tricky question because those of us who who try our best to find patterns, like me, are led to find a false pattern. So that's one trick, and then you need to have your wits about you and detect. Okay, look for another pattern. I'd rather have the attitude that I'm led to factor polynomials when the problem involves divisibility. A divisibility problem pertaining to polynomials, that should ring a bell, factor.
No.
What about adding? What if you add? Well, maybe two, because when you add polynomials, they cannot. Okay, if you want to tell if two polynomials are the same, whether there's a combination of polynomials obtained by adding, then my inclination is to multiply them out. Right? So you either factor or multiply out, depending on what the problem is.
Right. Now, notice that Seth and I, once we smelled the pattern, we took a whole different approach. What I did is I just tried each one, and I feel really bad that maybe someone is lost in what I did. So frankly, I'm a little lost in what Seth did, but let me go back to what I did. Let me give the example. You see, you have this relationship. F of x is equal to 2x of g of x. 2x times g of x, not of g of x. Sorry. 2x times gx, okay? So this here, what you do is substitute in. This is f of x. Look at the number b, right? F of x. But f of x, we're doing substitution, is 2x times g of x plus 3 g of x. See that? I just substitute f of x. I put this in now. Now I look at this and I factor out the g of x. G of x times 2x plus 3 equals the p of x. Now, here, that means which of the following is divisible by? Oh, we didn't mention that. P of x is divisible by 2x plus 3 because 2x plus 3 is a factor of p of x. That's really important. We skipped that whole concept. 2x plus 3 is a factor of p of x because it is is divisible by p of x because it's a factor of p of x. And
Yeah,
if you're not
that's what it means to
right
be
now,
divisible.
Now sometimes you get a little by like if the computer froze, give it 6 seconds. Maybe that's a little confusing. But what about bring it to a regular number? What about 12 times 3 is 36? 36 is divisible by 12 because 12 is a factor of 36. See that? See that? So you just go back and say, oh, I know that. And it applies the same to the polynomial, even maybe you don't think it does, but it does. Okay? And that's sort of a slower explanation as to what I did. But Seth did. Seth was a little smarter. Seth didn't just try. I would have tried each one. I would have gotten the answer. But notice I used substitution. Very important algebra. Very important algebra. I substituted f of x. I substituted this in. And Seth took the more like smarter approach of like figuring it out.
Let's see. Your approach would be, if you don't know, the systematic version of your approach would be to substitute. Where was it? I wrote it here. I'd rather write it like this. Substitute 2x times g into each one.
Into each of the answers.
Yeah, and then you will when you get to the second, you'll find that 2x plus 3 is a factor of the polynomial that you analyzed by substituting 2xg for f. Okay?
Right.
But that entails starting at the beginning, trying them, and then fortunately for someone taking the test, you hit the right answer on the second try.
Right. Yeah, they were nice about that.
Now. Approach. New approach. There's a 3 here. And there's a 2 here. Well, so that, and you're substituting f. You're substituting this thing with the 2 for f. Okay? So a 2 comes from substituting 2xg. And so pick an answer that has a 3 in the other term. So the 3 here would lead, so the 3 here suggests that if you're guessing which one to try first, it suggests that you guess B and then actually try it. And it turns out that using 3 to target your guess to be this choice will lead you to a lucky correct guess.
Oh, and C also has a 3.
I think well, the R is another possibility.
Yeah.
But when you verify that, and also when you verify that, you'll find it doesn't work.
Right.
However, the F plus 3G is a better guess because the 2 is already there.
Right.
The 2 is already there from here.
Yeah.
And the 3 it doesn't come from anywhere else. So the 3 leads you to pick this one.
But it all starts with this. If you don't factor the f of x like that, then you're never going to see the pattern.
That's right.
You're not going to, this is the key. This here is the key to it all. If you don't do that, that's it. And again, that's like a Pavlovian response, like a dog.
Yeah.
From the fetch. You see something, you factor the polynomial, and that's the secret. But here you don't overfactor, right? You don't factor like what Seth did, like over here. that's necessary. But this is the key to the problem right there. If you don't do that, then you have to be even smarter.
Yeah. Right? Well, yeah, that is what that overfactoring. Overfactoring is unnecessary because the SAT is designed these multiple choice questions is designed so exactly one of the choices is correct.
Yeah.
If your job was to pick all of those that are divisible by 2x plus 3, and then say if these were labeled Roman numeral 1, 2, 3, and 4, and then the answer A, B, C, D was 1 only, B only, A and B.
Right.
Though that kind of a question, that would entail that you need to rule out the others.
Right. But it's not.
But again, now let me on the top here, just point out at the ends of the video, what is the pattern that
good idea. Good idea.
Here is the pattern. The givens. Look at the givens. F of x equals 2x cubed plus 6x squared plus 4x. G of x is equal to x squared plus 3x plus 2. Now, what's the pattern? One. Now, I'm going to use red for one part of the pattern. See that? You go from here. The red pattern.
It'll come, everyone. Be patient.
We have say some term t here, and the top is 2t. That's the red pattern. But there's also a black pattern. X squared under x cubed, x under x squared, and x and 1 under x. The black pattern has, at the bottom, we have x q. At the top, we q. And so the truth of this is that you get from G to F by multiplying everything by 2 times x.
I think you have this backwards here.
F.
It should be XQ on top, shouldn't it?
Oh. No. This is the X. The X. No, you're right. Yeah, so the Q is either x squared or x or 1. Yeah, you go from G to F. You could go from the powers of x in the black boxes at the bottom to the top by multiplying it another x.
By multiplied by 2x.
And so the upshot of observing these two patterns is Joel's major conclusion that F is equal to 2 times X times G.
This is the heart of the problem. And it's very ironic that it's right in the center of the problem, because that really is the heart of the problem. Without that, you can't do anything.
Yeah.
Okay?
So look for patterns.
Yeah.
Look for all the pattern. Look for the entire pattern, not superficial features of it. You'll find the superficial features and then find all the features together.
Yes, Seth's still upset at himself for doing that. Now, it took Seth 50 seconds to find that pattern. Ouch. Good luck on this one, everyone. This is a toughie. This is a toughie. Okay, so, wow, that's it. Okay, everyone, have a great day. And please like us, dislike us, give us comments, help us tell us how we can improve these videos to help you approach SAT math questions. And if you have any SAT math questions you want us to go over, email them to us at satmathquestionoftheday@gmail.com. Bye-bye, everyone. And tomorrow is Throwback Thursday. Wow. Okay, bye-bye.